Huh. Well, I think it's that time I finally start making videos again. Maybe. Or at least one video. I'll make one video, and then in about half a year I'll be back again. That sounds like a fantastic plan. Anyway, today I want to talk about... actually... Alright, so today I actually wanted to talk about these things. So what are these? Well, these are high voltage DC to DC converters, specifically buck converters. These are pretty important in uses for like high voltage things, like our, I don't know. So you might recognize this little green fella from video by VidVX, which goes over testing these things and whatnot, because they're actually quite a desirable piece, because these guys can step the voltage down all the way from 120 volts down to 12 or 5, which you specify when you order these things. That's a very useful high voltage range, because our battery packs, like to a lesser extent like a 15S, one wheel battery here, this is the Pine X, they run a voltage from like 45 to 63 volts. So most buck converters that you'll find around won't actually go up to that range, but these ones do. The only downside is that you can only specify two output voltages, either 5 or 12. So that ends up being an issue when you want to power something like this. This is a one wheel XR light strip, and as far as I can tell, these take 18 volts, I believe, to run. I'm not sure if the voltage is the same between the red and the running lights, but it's some weird voltage. It's not like a 12 or 5. Like, for instance, these guys here are 5 volts. These are for the pint, and they're addressable LEDs, and they run off a 5 volt rail. So right off, you can't really use the 12 volts or the 5 volt version to run the XR lights unless you boost them back up, but that's kind of an unnecessary, efficiency loss. You don't want to have to step down a voltage and then step back up a voltage. That's redundant, and it's just a pain in the butt. However, what I have found out is that you can actually specify any voltage that you want on one of these guys. So I did a lot of testing with trying to figure out where. Here, I'll bring the camera down, I can show you. This is how they come. Pretty small buck converter, capable of outputting, this is a 12 volt version at 3 amps, so that's quite a bit of power. That's a relatively good conversion rate, and I think they're fairly efficient too, probably in the 90s, high 90%, I'm not sure. But this is the one I was working on initially. I just pulled the resistor off. This is what it looks like underneath the heatsink there, and I'll put part numbers. I'll pull up an image of all the components, but that's what it looks like under the heatsink. So we've got a fairly small MOSFET there and a few diodes, and the driver for that MOSFET is that little IC there. But the components that we want to worry about when changing the voltage is this guy, R7 and R8. As you can see, I was soldering there, and that's why it looks like an absolute mess. So by default for the 12 volt version, those are, what value? Like 100, I think they're 120 kilo ohms, 120K. And if you change those values around, you can specify whatever voltage you want. So actually the math here is really simple. So the 12 volt version will have 120Ks, the 5 volt version will have 50Ks. So it's 10K for every volt you want. So in terms of my situation, I need 18 volts or whatever I don't know what voltage these are, but I need 18 volts. So what I've done is I desoldered those, and I've got this one. And I don't have any surface mount resistors, so I kind of just rigged up these through holes. I bent the wires flat so that they'd sit on the surface fairly well, but this has a ohm value. I think I combined like a 150 kilo ohm, because I don't have the exact value either, but I have like a 150K combined with I think a 39 or something. It outputs around 19 volts, so let me zoom out a little bit. And I haven't actually tested up to the maximum range yet, but you guys are going to be able to see. In theory, this should be able to output 18 volts at 3 amps, just like how it can go 12 volts at 3 amps and 5 volts at 3 amps. So for the test, what we've got going on is we've got the buck converter going into a boost converter, and that boost converter is dumping all of its power into this this ceramic resistor, and then I've got a little water tub that this resistor will sit in, and that will allow us to change the load. So I don't have a load tester, but I have an adjustable boost converter as well as a power resistor. To start the test, I'm going to put in 30 volts, or right around the maximum that my power supply can handle. Max it out here. So that's 32, and I'm going to put that into the buck converter. So that's on right now. Ooh, it's yeah, that's definitely on. So I'm going to back off on the booster. So I've just set the voltage of the booster to not boost anything above 18 or whatever this is at right now, but let me get my voltmeter up and we can look at the value of the voltage coming out. So I've got this one at 19.5 that it's outputting. It's pretty stable without any load on the output. However, I believe if I disconnect the load, yeah, it goes to 20.5 and kind of jumps around a little bit. I don't believe that's normal. It could be, I don't know, something with how I've got my resistors hooked up, or the I might need to change other components. I'm not sure, but under load it's fairly stable, so I'm happy with that. I also noticed that if I touch one of these, I bring the voltage to different values, which is really weird. If I ground myself too, yeah, you can see I'm manipulating it just by touching the ends of these, which you should probably snip those off. I wouldn't leave those there, but let's go on with the test here. So I'm gonna reapply the load, and that's gonna drop it down to 19.5. So right now we're pulling, it says 26 watts at 0.8 amps. That's nice and all, but what I really need to know is what the output is. So I know this is not going to be the most accurate thing in the world, but it'll give us a rough idea of how much current's coming out. That really does not help. You see that? Okay. Okay, you can see that. So right now we're outputting 1.2 amps, which is respectable, but we can go further. So I have a few of these, so I'm not worried too much about blowing this up. But we're going to test it out to the maximum, so I'm going to just adjust this potentiometer until it starts to change the, I think it's backwards. Yeah, okay, so I'm changing the load now. You know, it would be nice if I had, just as proof, actually, oh, uh-oh. Ah, catastrophe. So this way you'll be able to see both the output voltage as well as the current coming out. Alright, so at 19.35, give or take. We're at 178 amps, so we should be halfway through our capability. And the heatsink is a little bit warm, not too bad. So let's go up. The voltage is pretty stable as I go up. It's 2.5. This is 57 watts now. Okay, 3. So when I tested these before, as they were stock, they couldn't, I don't think they could sustain 3 amps without active cooling. And it's getting, yeah, the heat sink's a little bit hot now. This thing's cold. Can see bubbles forming. So we're at 3 amps. This thing should have over temp protection, I think. Though I'm not really sure how it's getting the temperature of the heatsink now that I've taken it apart. There's no, is there any thermal probe in there? I don't know. It might be in the MOSFET. That might be a built-in function of that thing. I'm not sure. Oh, look, we've, wait, what just happened? Hold on. We're pumping in 3 amps, but we're not getting power on the output. Hold on. I may have run into a problem. You know, it might have already shut off, actually. Back off the booster here. Okay, we're back at normal values. Let's go up again. I don't know if that was caught on video, but it looks to me like it shut. Oh, yeah, look at that. I think what we're running into over current limit or something. Okay, 19. Let's ease it up. When does it trigger that? That's interesting. So something tripped and it wouldn't come back on, probably because the booster's overloaded. Like when you lose the output voltage on the booster, it's really hard to get it restarted when you're demanding such a high load on it. So I'm right below 3 amps, and right now it's holding, but I am kind of expecting it to drop. It's right at 3. I'm wondering if the cutoff is really that accurate. I'd expect it to maybe cut at like 3.5, but that's cool too. Oh, yeah, right there. Wow. Okay, let's back off a little bit. Restart. No, doesn't like that. Doesn't like that either. On. Still no. Okay. There we go. Yeah, let's get it right back to where it was before. Just do a duration, you know, longer duration, make sure it can sustain that for a while. Oh, yeah. It's quite hot. So luckily you wouldn't be really experiencing these kinds of loads with the XR lights. These pull not a lot of power. Yeah, booster's getting a little warm. We're pushing 62 watts through this thing, which is kind of impressive. So in theory, you know, if you output a higher voltage like 30, which would be kind of the maximum, you could get 90 watts. You get 90 watts out of this thing, which is kind of crazy to think. That's a lot of power. How's the water? Water's still cold. I'm sure that's gonna change, but yeah, it's holding right here at 2.97, right at pretty much 3 amps, holding at 19.5. 19.5 is a bit high for what I need, so I'll probably change the resistors around, but anyway, that's pretty cool. Now I'm going to show you guys how to convert one of these 12 volt modules into an 18 volt module, or close to that. So what I ended up doing is I got some of these through hole resistors. There's 2 values here. I believe one of these is a 100K and the other is like an 82K. But if you have a 180 kilo ohm resistor, you can do the mod just as well. I'm just pretty much adding 2 resistors together to get the value that I need, which is 180 kilo ohms. So to specify the output voltage of one of these, we have 2 resistors that we need to change out to the same value. So how this circuit works, essentially, there's 2 feedback pins on the IC, which is this little guy right here with the 8 legs. There's only 4 sticking out, but 2 of those are used for feedback sense. The whole resistor cluster right here is responsible for telling that feedback pin, or those 2 feedback pins, what to do. So essentially we need to remove the 2 resistors labeled R7 and R8. There's R7A and R8A, but those are different, and you want to keep those the same actually. So you'll see on the 12 volt buck that the resistor value is 120 kilo ohms. That's what the 124 stands for, and you want to basically remove those. So one of the ways I figured out how to do that is you want to get a good amount of solder on your iron here, right on the tip, and then you want to try and hit both of the sides. So you want to try and hit both pads, basically just completely consume the resistor, and then you can kind of like suck it up. You can basically dislodge it just by doing that. Now the resistor is on my iron. So after that's done, I'd take a moment just to clean up the pads. Just a little bit. Kind of heat it up. You do want a little bit of solder right on the pad there, just so you can have something that already exists, so you can put on the through hole resistor here. So let's do it to this other one. This one's a lot easier because I can get a nice shallow angle on my iron. Perfect. I reckon I'm never going to use these resistors, so I'm just throwing them around. You can buy SMDs pretty cheap anyway, which I guess I would recommend doing if you know how to put them back on. I find that it's much more a pain in the butt to put them back. Alright, so now that you have two vacant pads, or resistor spots, I guess, you can basically make one of these, which is just two resistors that I've pinched together on one side and then soldered the end. So take one end with some tweezers. Do not have the most steady hands for this, but I can try putting my hand on the table. That stabilizes me a little bit. Clean my iron off a little bit. You want a nice clean iron like that. Perfect. Alright, so I would do the inside one first so that you can get at it from this angle or something. And I would do this. You can bring one leg of it down at once. So start on that side. So after you have one attached, you can kind of hit the other one and then push it down on one side, so you kind of angle it over and then kind of rock it back and forth until it's all the way to the bottom. That's what that looks like. Second one's a bit easier because you can get that shallow angle. You can see I put one pad down and position the other, kind of just rock it. It's already pretty good, honestly. Oh, get off. Alright. So, just as a final thing, let's kind of retouch these. Ideally, you don't want solder balls, but I mean, these are going to be fine. I think this should work. But let's give it a go. Hopefully that doesn't explode, but that is on. Take some readings off of here. See what it's doing. Alright, there you go. So we've got 18 volts on the output. It's jumping around a little bit, but if we load it with something, that problem should, in theory, go away, like it did before. So I'll take this power resistor out real quick and tap off of these. And you can see it stabilizes around 17 volts. So what that drop is about, I'm not entirely sure. But I would just compensate by, putting a different value in there, maybe overcompensate by a volt or two. That's kind of what I'm gonna aim for, but you can change the output of these just as proof of concept. Right now we are drawing 20 watts right now. Of course, I don't have the boost converter set up, but I mean, realistically, this should be able to handle 3 amps on the output just like the other one does. Voltage doesn't matter too much in that regard. Resistor's getting hot. Yeah, okay, let's stop that test. Anyway, that is how you convert one of these guys to be any voltage that you want. The range, though, actually is from 5 to 30 volts is what that IC specifies. So I wouldn't necessarily try to go above 30. I'm not really sure what happens if you get to 30 and beyond that, but you're welcome to try. I mean, I bought like 8 of these things because I know their shipping is kind of all over the place, but they're good. They're good designs. I mean, it's much better than designing your own and having to troubleshoot why the heck it's not working, because it already exists. So, you know, go crazy. Anyway, I'll see y'all later.